Okay, so let's have some fun with calculations. So here we've got a reaction between aluminum and Cl2 generating aluminum chloride. So what's aluminum chloride? Well, again, ionic compounds, we'll note aluminum in column 3A forms a +3 charge. Chlorine is a -1 charge in column 7A. And so aluminum chloride has the formula AlCl3. Now, we need to balance this. All right, and so to balance this, what we're going to do is we're going to add coefficients for a 3 in front of Cl2, 2Al, and 2AlCl3. Now we have a balanced reaction. All right, moving on to part B, we've got the mass of two different reactants. So this is going to be a limiting reactant problem. When you're given the mass of two different reactants, you need to ask which of these is a limiting reactant in order to figure out the amount of product. So the first thing we're going to do is we're going to calculate the moles of each. And so we'll start with aluminum. So we have 2.70 grams. And now we're going to divide it by the grams per mole of aluminum. So 1 mole of aluminum, 26.98 grams of aluminum, is going to give us 0.100 moles of aluminum. We do the same thing with chlorine. We have 4.05 grams of chlorine. And the molar mass of chlorine, diatomic chlorine, is 70.90. Now remember, there are 2 chlorine atoms, so that's why it's 70.90. So that's going to give us 0.0571 moles of diatomic chlorine. All right, so which one's a limiting reactant? This is where you have to be careful. There is going to be a tendency to say that the chlorine is a limiting reactant because it has fewer moles, but you need to pay attention to the stoichiometry. If the stoichiometry is 1:1, then yeah, the one with the fewest number of moles is going to be your limiting reactant. But if it's not 1:1, you have to be careful. In this case, we'll note that we're going to react 3 moles of chlorine with 2 moles of aluminum. So it's not 1:1. There are several ways you can go about doing this. Probably in the long term, the easiest and less confusing way to do it is just simply to calculate the mass of product for both. Now, I can look at this and tell you that clearly based on the 3:2 ratio, I need more moles of chlorine than of aluminum. And clearly I have fewer moles of chlorine than aluminum. So in this particular case, I could say, yeah, the limiting reactant is diatomic chlorine. But let's go ahead and calculate the amount of product for both. So we'll start with aluminum. And with the aluminum, here we're going to calculate the mass of aluminum chloride from the aluminum starting amount. All right, so we're going to have here 0.100 moles of aluminum. And I'm going to note based on my stoichiometry that I get 2 moles of aluminum chloride for 2 moles of aluminum. So it is 1 to 1, but I'm just going to go ahead and write that out. So 2 moles of aluminum chloride for 2 moles of aluminum, and moles of aluminum cancel, and so I get 0.100 moles of aluminum chloride if aluminum is my limiting reactant. And actually, I said do the mass, but actually we'll just do the moles. It's just easier to calculate moles of aluminum chloride. So the moles of aluminum chloride, if we used all of the aluminum, would be 0.100. So now let's do the same thing using chlorine. All right, and so here we got 0.0571 moles of chlorine. That's what we calculated. All right, and using our stoichiometric coefficients, I've got 2 moles of aluminum chloride per 3 moles of chlorine. And again, that's just based on 2 and 3. All right, so that's what I've got. And so when I calculate the number of moles of aluminum chloride based on that, I get 0.038. Let me get all this figs here. 0.381 moles of aluminum chloride. So clearly, fewer moles of aluminum chloride with the chlorine. So just as we had said, chlorine is our limiting reactant. All right, so now we just need to calculate the mass of the aluminum chloride based on its molar mass. So we're going to take our 0.0381 moles of aluminum chloride, multiply it by the molar mass of aluminum chloride, 133.3 grams per mole. So that cancels out. We've got grams of aluminum chloride for my answer, and the value that we get is 5.08 grams. All right, so there we have it. The chlorine, the diatomic chlorine is our limiting reactant, and using the mass of the diatomic chlorine that we're given, 4.05 grams, calculating moles, we can figure out the moles of aluminum chloride and then the mass of the aluminum chloride. All right, now finally we need to calculate the percent yield from this. And that's just the actual amount divided by the theoretical, what we just calculated, times 100. So that's going to be 3.25 grams is the actual amount, divided by 5.08 grams. The theoretical amount times 100 gives us a percent yield of 64.0%. Okay, so there we have it. Limiting reactants. We need to calculate the moles of both reactants and use the stoichiometric relationships to figure out which of those reactants will determine the theoretical yield of our product. So let me know if you have any questions.